So let's start today with three-dimensional shapes. In the last lesson, we spent a lot of time talking about perimeter and area of different 2D shapes like circles, triangles, rectangles. Today, we're going to go to 3D. And I would like to know, if I label this shape A and this shape B, what are the names of these two shapes? What are the names of these two shapes? So it's hard to tell if these are equal. So if these were all equal, it would be a cube. Although for me, what I'm going to say is that these are different. That's a rectangle over there. So I think this would be a rectangular prism. You can say cuboid. Cuboid is also, except if something is a cube, it would have to have all equal lengths. So it may be that it's just the distortion, but to be safe, I've gone with rectangular prism, but it does depend on the lengths of the base. Now, when we talk about the rectangular prism, there's two things we're normally interested in. We're normally interested in something called the volume, which is how much stuff fits inside here, like how many sort of sweets could you fit inside? And we also talk about something called the surface area, which is a bit like the wrapping paper. I call it the wrapping paper effect. How much wrapping paper would you need to cover this side, this side, this side, that side, that rectangle at the back, and then maybe the rectangle in the front. So there's 6 faces that you would have to work out the area for surface area. And for volume, you would just find the base of the shape, which is a rectangle, and times by the height. Then the second one is a triangular prism. And we'll talk about finding surface area and volume for this today as well. Why is it a triangular prism? Well, it's basically a triangle, and then it's a whole bunch of triangles stacked on top of each other. And that's it. So, and then what you have is the 2 triangles, but then you also have 3 rectangles going around the outside. But for now, you just need to know the name. Okay, what type of shape? Let's call this C. What shape is this? So this is a cylinder. And a cylinder is really just a whole bunch of circles stacked on top of each other, where the circles are all the same size. And if we imagine what makes up the circles for volume, it's a whole bunch of circles. For the surface area, we have to worry about 2 circles, and then also whatever shape that is. And so we have to think about what is that when we untangle it. Okay, cylinders, you need to know about that. Now, we're not going to get into the super deep tonight, maybe in the lesson on Monday. What type of shape is this? Makes me think of a little bit about Egypt. So this is a pyramid, but it's not just any pyramid, because you talk about the base of the pyramid, which is important, and that is a rectangle. And so because that's a rectangle and it's going up to this apex here, we'll call this a rectangular pyramid. And when you think of a pyramid, you're just going to think of it going to a pointy bit here. And also the pyramids that we deal with in grade 11 all have a right angle here. And so what's going to happen is that at some point in the future, you're going to see the theorem of Pythagoras is going to help you figure out what this thing over here is. And this thing is called the slant height. So in the land of pyramids, that thing is called the slant height, and this is called the altitude. This one over here is called the altitude, or just the height, or h, that's the sort of perpendicular to the ground height. Okay, and so for this shape, it's a bit more tricky. We seem to have 4 triangles on the outside and then a rectangle at the bottom. So we're going to have to think about that for surface area and volume and how that works. What shape is this? What shape is this for E? So this is a cone. Yes, think ice cream cone. And a cone is based around the idea of a circle. And then you've also got sort of the cone bit. So we need to figure out like what sort of shape that makes if we unravel it, I guess. We also have this right angle triangle thing going on where the center of the circle is directly above the apex there. And then there's this bit that comes down here. So Pythagoras will probably be involved. And yeah, that is the cone. And then the last one that we need to be aware of in grade 11, what is this shape? So that is a sphere. Okay, so in grade 11 measurement, we need to know what these shapes are. So let's have a look. We've got the prisms, the cylinder, the pyramids, the cones, and the spheres. We're going to mainly focus on these two today, but the main ideas throughout are going to be about finding the surface area and the volume. The surface area, I like to think of as the wrapping paper around the shape. How much wrapping paper do I need to cover the shape? Okay, that's for surface area. And for volume, how much stuff, how much fits inside? And we think of volume, we're going to talk about units being cubed. So units cubed, and that's because it's how many little cubes actually fit inside something. When we talk about surface area, we're going to talk about units squared, because we're going to talk about how much, sort of how many squares does it take to cover the outside of the shape. Give me a thumbs up if you're okay with everything I've done so far. Because we're mainly just doing vocabulary in measurement. So welcome to Alexa, Amogelang, Busisiwa, Callan, Ganlin, Livu, Naledi, Onalena, Pufunzo, Pila, Reniwe, and Siamtando, who have also joined us. Okay, so just some more vocab. There we go. You can see the shapes here. These are the cylinders, the prisms, the cones, and the pyramids. All good. Just some fancy words. We talk about the base of a shape. So this is kind of the base, and then the lateral faces, and then the height. And yeah, this is all just, I mean, it's not really that important at this point. Maybe the slant height is important for a pyramid. And we also talk about the slant height in a cone. So that's something which in future we will talk about. Like this thing on the outside, which we're calling the slant height. Over here, the slant height could also look like this. Okay, let's go and do some questions around surface area and volume. So here is a cuboid. Oh, sorry, earlier on you said cuboid, not cube. So this is a cuboid, you're quite right. Over here, I want you to work out for me, what is the surface area of this cuboid? So go ahead, see if you can do it, and then get me the answer for this one over here. I'll give you a hint that there's 6 faces that you need to work out the surface area for. And I'm going to get my calculator, so what have we got? So I guess we've got this one and its matching friend over here. So that would be 2 times 3 times 5 plus 2 times, well, we're going to probably going to have this one, which is 8 by 3. And that would have its matching one over there. And then on top, what are we going to have? We're going to have 8 by 5, but there's 2 of them because there's one on the bottom as well. So we will have plus 2 times 8 times 5. So that would be, what's that, 30 plus 48 plus 80, 78 plus 80, 100, and what do you guys get? 158? I get 158. Anybody with me on C? Let's have a look at the chat there. Okay, so for those who are feeling a bit confused, I just want to go over, okay, so I've lost some of you. Okay, let's have a look at this. So I want to suggest that for surface area, there are pairs of rectangles that I need to add up. So the first pair is here, and that's going to be, and then it's going to have a matching friend over here, which is also going to be red. And so I'm going to say 2 times 3 times 5. Then I've also got over here, there's 3s, right? All of these are 3 high. Now, what about the front facing bit here? This is 8 by 3. So this part over here is going to be 8 by 3, but so is the part at the back. So now I've got 2 times 8 times 3. So maybe I should color in the back part there and then the front part. But now what about on top? On top, this is 5 and this is 8. And the top and bottom, so that's 2 times 5 times 8. So I've got to add all those up, and then I get 158 centimeters squared. Give me a thumbs up or thumbs down if it makes more sense now. Okay, it was just our first one. Don't worry, we're still warming up for this. Find me the surface area of this cuboid or this rectangular prism. Find me the surface area of this one. Now, I'll give you a hint again. Think about, there's this one and this one. So maybe we can go 2 times whatever they are. You also have that one and that one. So that's why I'm going 2 times. And then I've also got whatever that is in the back and whatever this is in the front. So we'll go, in fact, let me undo that because it gets a bit messy now. You can kind of imagine where that is. 2 times whatever those are. Now you have to get me an answer for the surface area. Let me see what I get. So this is 12. That's 24. And that's 16. That's 32. And that is 96. So I get 152 centimeters squared. Again, give me a thumbs up if you understood that. Give me a thumbs down if you didn't. Now, I'm going to upgrade this question. Instead of the surface area, I want to find the volume. Now, when we find the volume, we're basically saying, what is the area of what in one rectangle and how deep does it go? So can you find me the volume of this rectangular prism? And I'll give you a hint. You always want to find the area of the base, but then you have to do something else as well. So the volume is just going to be 6 times 2 times 8, because it's this, and then is basically it's 8 centimeters high. So I'm going to get 96, but the units are going to be centimeters cubed. So it's important you understand the difference between volume, which is 96 little cubes that fit inside here. You can imagine there's one little cube, there's another, and 96 of them are going to fit inside here. Whereas with surface area, we're talking about the wrapping paper. Like, how much does it take to wrap this? Okay, let's do this one. Can you find me the surface area of a cube-shaped box without a lid? There is no lid. This top bit here is empty, open. What is the surface area of this cube-shaped box without a lid? What does it mean if it's a cube? It means this is the same as this, and this is the same as well. This is a 2.5 centimeters. Well, let's think about the sides here. What are these two red ones going to be? Let's write them as 2.5 so it's not confusing. And then we're also going to have the front and, well, we can imagine the front and back, right? Like this one in the back and its friend in front. So that's also going to be 2 times 2.5 times 2.5. But then the bottom isn't going to have a matching friend. The bottom is going to be all by itself, in which case we just go plus 2.5 times 2.5. What are you getting in the end then? 2 times 2.5 times 2.5 plus, actually, it's just doubling that because there's 2 of them, plus 2.5 times 2.5. I get 31.25 meters squared. Sorry, that was meters, and I said centimeters, but I actually meant meters. Give me a score out of 10 for how you are feeling about surface area and volume of a rectangular prism. 0 is that face. That face is 5. That face is 10. How are you feeling about this so far? Okay, your numbers are super helpful. I can see I need to slow down a bit. So I'm going to slow down because I can see people are saying, look, I get it, but I'm feeling a bit shaky. So don't stress. That's the beauty of the number system. So we're going to slow down a bit. Now, this is a similar type of question, but not the same. It says calculate the surface area of the triangular prism. So I would like you to have a crack at this. The only hint I'm going to give you is I'm going to say, look, it's made up of 2 identical triangles, and then there's 3 other rectangles. Can you use what you learned in the last lesson to work out the surface area of this triangular prism? And I'm going to give you some time to do that now. Welcome to Wasile, who just joined us. And welcome, who else is, I think I've welcomed Livu. And who else? Yeah. So I'll give you a chance now to work out what is the area of this triangular prism. Let's get started. The area of a triangle is a half base times height. Can you figure out what you would put here, and then how you would deal with the fact that there's two of these triangles? I think all of you can see the base is 8 and the height is 6. And then a clever thing to do is to times that by 2 because you have two triangles. Now you still have more work to do though. And then once you've got your answer, won't you choose your option in the chat? What type of shape is this one over here? Let's have a look at this. This looks like, to me, a rectangle. And the length of the sides are 7 and 10. So I'm going to go 7 times 10 for that one. Then for the one on the bottom, it's going to be plus 8 times 10. And then the one over here that is facing us, I think that is 10 times 7 as well. So there's 3 rectangles and 2 triangles. That's perfect. Okay, let me see if I can add these all up. So for the top bit, it's going to be 48. So this, I mean, you can do it all at once. This is 70. This is 80. This is 70. So 48 plus 70 plus 80. I seem to get 268, and it's centimeters squared because of the wrapping paper. So I get B. Now, I would love some questions. I can see some students are struggling. I would love a question from a student as to where am I losing you? So if you think about how I did this, there's 2 ideas that I needed. The one is, what is the area of a triangle and what is the area of a rectangle? I also needed to know that there were 2 identical triangles and there were 3 possible rectangles. For the triangle, it's a half base times height. For the area of a rectangle, it's just length times breadth. Give me a score out of 10 for how, now that you've seen me do it, give me a score out of 10 for how you're feeling about this example. We're going to do another one of these now, but I just want to see if you understand my method. Okay, cool. So we're all on the journey. We just need more practice. So I'm going to zip my lips and I'm going to let you guys do more practice on the next one. And in fact, should I do, no, let's not do that one. Let's do this one over here. Okay, here is a triangular prism. I'm going to ask you to find me the surface area of this shape. What I'm going to point out is that this length over here is 7. But there's a whisker over here. What does this whisker mean when it's the same whisker as that? What is that mathematical way of telling us something? It's not parallel. It's equal. So what it means is that this is also 7 centimeters. Okay, now I've given you the help there. I want you to work out how much wrapping paper do I need to cover this triangular prism. I can see my triangle at the back. Let me use a different color. I can see my triangle at the back, and it has a matching triangle in the front. But from there, I want you to take it. I want you to work out what is the surface area of this triangular prism. Trying to get some water while you work on that. This 3 is going to be important because that's the height. What surface area are you getting? Let's have a look. So a half times the base times the height, but then I need to double it because there's 2 triangles. So there's the triangle here and the triangle in the back. They are the same. They're identical. Then I have my 3 rectangles. I have the rectangle that is 3.5, and that is 12. So the blue rectangle is going to be 3.5 times 12. The green rectangle is going to be 7 by 12. Now, what is the final rectangle going to be? What's this one over here? Well, that's also 7 by 12. So what is my surface area going to be? Let's have a look. So plus 3.5 times 12 plus 7 times 12. 12. I get 231 centimeters squared. And so does Reniwe. So does Callan. This is great news. Okay, before we take our break, I want to upgrade this question. And the upgrade is I want to know what is the volume of this triangular prism. So this is a triangular prism. I want to know what is its volume. And the hint I'm going to give you is that the base of this shape is just this triangle over here. So this whole shape is based on the triangle over here. It's like a whole bunch of triangles stacked behind each other. Can you work out for me what the volume of this shape is? And then we're going to take a break. We've earned a break. Then we've done well. I would start by finding the area of the yellow triangle. What's the area of the yellow triangle? We're going to go a half base times height. So 7 times 3. And then what do we need to do next? Now, we don't add extra bits. What we do now is we actually times it by how deep this triangle goes. So we've got the area of the triangle, and all we need to do is times it by 12. In some ways, volume is so nice, actually. It's so much simpler than surface area. 7 times 3 times a half times 12. And I get 126 centimeters cubed. So I just want to point out the difference between volume and surface area. Volume is how much stuff fits inside. All you do is find the area of the base, and then you times by the other, like the depth of that shape. So like how deep the triangle goes into the page. Whereas surface area, I really need to go around the outside and count all the surfaces and work out their area. Just give me a score out of 10 for how well you understood the volume. Give me a score out of 10 for how well you understood the volume. Okay. Let's take a little break before we go any further. So you know what it means. Please step away from your desks or your tables or wherever you find yourself and stand on your feet and join me in just taking care of your body and your mind. So let's start with some breaths in. Breathe in. Breathe in. Breathe in. Okay, shake out those arms, get them nice and loose. You want to feel all the stress just melt away, no stress in your body. Shake those legs, give them a good shake. I can feel how relaxed I'm becoming. Feels fantastic. Let's roll the shoulders back a little bit. Roll the shoulders, roll them back. Let's roll them forward. Okay, arms to the side. Let's make some small circles. So we're just making little small circles and we're going forward. And now we're going backwards. Okay, then one more shake of the arms. Give it a nice shake. I feel nice and loose. So I've got some oxygen, I've relaxed my body, and now I'm going to get blood flow. And the way we get blood flow is jumping jacks. So this is a jumping jack. Join me. Make sure that the space around you is clear, and we're going to do 15. In 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and take a deep breath. Woo. And I want you to give me a thumbs up if you did 15 jumping jacks, really. So I'm going to give a thumbs up because I did 15. Edith is being very honest. There we go. Ooh, I love it. It's good. Honesty. Tandiwe, I see that. There we go. Come on, give the honest truth. I actually feel fantastic now. I feel alive. I promise you, you may think I'm a crazy old man on the TV, but the stuff works. Okay, let's do one more. Let's do one more of these triangular prism things. Can you find me the surface area of this triangular prism? So I want you to go by yourself, get stuck in. Can you find me the surface area of this triangular prism? So I'm going to say a half times 3 times 4, but I'm going to double it because there's this triangle and there's this triangle down here. Now, you still need to figure out a bit more. What do you get for the final surface area? Okay, so for the blue one, I get 4 times 10. For the red one, I get 3 times 10. And for the black one, what do we need? We need an old friend. Who do we need to help us? Who are you going to call when you've got two sides of a right angle triangle? Come on, who knows what this is? I know someone knows it. It's just itching on the tip of your tongue. Pythagoras. Yes, Pythagoras. So if this is 3 and this is 4, by Pythagoras, this must be 5. So this would be 5 times 10. So what is my final surface area going to be? 40 plus 30 plus 50 plus 12. I get 132 centimeters squared. Don't forget that you need to double both these triangles. So give me a score out of 10 for how you're feeling about surface area of triangular prisms. Keep the votes coming. Okay. Thank you. That's very, very helpful. Now, before we move on, I also want you to find me the volume of this triangular prism. What is the volume of this triangular prism? I'll give you a hint. You only need to really worry about the base and one other thing. What is the volume going to be? So all you're going to do is go a half base times height, but you must get the 3 times the 4. And then the other dimension for how deep the triangle goes is just that, is 10. So times 10, which is a half times 3 times 4. That's the area of the triangle, but then times it by 10, I get 60 centimeters cubed. So just think, when you're finding the area, you need to use the base and the height. And then you think about how tall is this thing, and it's 10 tall, 10 centimeters tall. All right, there's more practice questions like this in the quiz today, but I'm going to move on to another shape. We'll leave triangular prisms for another. We're going to talk about our friend, the cylinder. So it says here, Meg wants to calculate the curved surface area of the cylinder. So when Meg says the curved part, she doesn't mean the flat circle on top. She means the bit, sometimes they call it the lateral surface area, the bit that goes around here. She draws the rectangle to help her. She has 10 centimeters. So basically, this 10 centimeters here is the same as that 10 centimeters there. Give me a thumbs up if that makes sense to you. Another way to see this is if you take a piece of paper and you fold it. So let's see if I've got a piece of paper here. I've got a piece of paper. So here is, it's a little bit crumpled, but here's a rectangular piece of paper, right? And I can sort of curl it up This paper is a bit folded, but I can basically put it into being like a circle like this or a cylinder, and yet when I unwrap it, it becomes a rectangle. So that's kind of what they're doing. They're saying, look, just cut it here and it's 10. Now, what I want to know is what is this length over here of the 4 options here? What is the length of the 4 options that we have here? Is it A? Is it B? Is it C? Is it D? So imagine taking some scissors and cutting it here. What would this unravel to? I think this length is actually, it's that thing, whatever that thing is called. And that thing is called the circumference. So when we unravel a cylinder, we have a circle on the top, a circle on the bottom, and then we have this rectangle where over here we have the height, and then this thing over here that goes the whole way around, that is going to be the circumference of the circle. Now, we do have a formula for the circumference of the circle. It's diameter times pi, or it's 2 pi r. We did that in the very first lesson. So we're going to see how this might help us in the next example. So this is what you need to bear in mind. Let's see. Give me a thumbs up if you feel like you could take this question on by yourself. Give me a thumbs down if you think, no, I need an example first. I need an example first before I can get going. Okay, we have okay, I'm going to let people start, but then I'm not going to go too far before we get, okay, all right, a lot more fingers. Okay, so what I'm going to say to you is this. If you imagine, let's start by figuring out the area of this top yellow circle. The formula for the area of a circle is pi r squared. So the area of the yellow thing will be pi 7 squared, which is the same as 49 pi. Thumbs up for that. Thumbs down if, okay. Now there's a second circle that I need to include. So what I'm going to do is I'm going to say 2 circles is just going to be 49 pi times 2, which is 98 pi. Awesome. Now all I need to do is find the area of the rectangle that goes around the outside. I want to know, and I can maybe even make it bigger. If I say to you, what is the length of this line over here, the blue squiggly thing, what is the length going to be for that? Based on the drawing that we see here, I think this has to be 13 because it's just basically this bit over here. Now, when I open this, I need to find this thing over here to be the circumference. Can you work out for me the circumference of the circle? What is the circumference of the circle going to be? You know the radius. What's the circumference going to be? Well, the diameter would be 14. So if I doubled the radius, the diameter would be 14. So it's part of it. It's 14 for the diameter. But then to find the formula for circumference is diameter times pi, or it's 2 pi r. And 2 times 7 is 14. So what we see is that circumference is 14 pi. Give me a thumbs up if you understand why the circumference is 14 pi. Okay, now on my rectangle, oh, you don't, okay, for those who didn't get it, look at how I doubled. If I take the radius, it's 7. If I double the radius, I get 14, which is the diameter in this thing. Or if I put a 7 there, if I put a 7 here, 2 times 7 is going to be 14 pi. That thing is going to be here. So now, in order to find the area of the rectangle, what am I going to get? Well, this is going to be 14 pi times 13. So I'm just going to go 13 times 14. I get 182 pi. What is the surface area of the whole shape? I just need to add together these two. So 2 circles were 98 pi. The rectangle was 182 pi. So we go 98 plus 182, 98 plus 182, and I get 280 pi for the surface area. Now, if you want to actually put a full number in there, you just go 280 times pi, and you would get 879.65 centimeters squared. Okay. Now, I know that was a toughie, but are there any questions before we move on? We're going to do another one in a moment, but I just want to get a feel for, like, thumbs up if you feel like there's some hope. Thumbs down if you're like, whoa. Okay. I'm going to let you loose then on the second question. So here is a new cylinder. I want you to find me the surface area of this cylinder. Find me the surface area of the cylinder, and you're going to do it all by yourself while I drink some water. So can we change the pi to a decimal? Yes, you can, Edith. You can indeed. Ooh. Ooh, it all seems a bit stuck. Oh, well. I'll deal with that after the lesson. What are we going to get for the surface area of the cylinder? Okay, circle pi r squared, but they were sneaky here. The diameter is 4, which means the radius is 2 centimeters. So that must be 2. But there's 2 circles, so I times by 2 again. Plus, there's another part I need to think about. See if you can find, let's try and find the circumference, because that is what goes here. So C would be 4 times pi, or diameter times phi. Oh, that's nice and easy. So this would be 9.5 times 4 pi. And I've got to add all these together. So what have I got? I've got, so pi times 8, because it's 2 times 2 times 2, plus 9.5 times 4 times pi, and I get a surface area of 144.51 centimeters squared. So that wasn't too bad. Where did I get the 8 from? The 8 came from over here. So thanks, Amelia, for the question. 2 squared is 4, and then 4 times 2 again is 8. So these things together give you 8 times pi, and then plus the 9.5. So yeah, basically this circle and this circle are taken care of by this. And then the rectangle over here is this bit here. Did that help, Amelia? Okay. Now, bonus question. I want you to work out the volume of this cylinder. Can you work out for me the volume of the cylinder? And the only tip I'm going to say to you is a cylinder is based around a circle. And see if you can take the ideas from earlier on and think about what you need to find first and what you need to do after that. Can you find the area of the green circle? And then what else do you have to do to get the volume of the cylinder? Let's have a look. A half. Oh, wait, not a half because it's not a triangle. Watch out. Pi r squared is what I want. Pi r squared is the area of a circle, but I need to put a 2 there because the radius is 2. So pi r squared, but then I also need to times it by how many circles deep it is. So times 9.5. So what's that going to give us? Times 9.5. I get 119.38 centimeters cubed. So volume is actually super awesomely easy. And I'm going to move on unless there are any questions. So I'm going to look at the chat. Are there any questions or comments? Just raise your hand. You can ask an audio question if you like. Otherwise, I'm going to move on. Okay, let's see. Are there any other ones? Let's do this. Can you find me the surface area of this cylinder? Can you find me the surface area of this cylinder? Can you find me the surface area of the cylinder? And then when you found the surface area, can you find me the volume of the cylinder? So what do we have to do here? We know we have pi r squared, and the r is 4, and there are 2 circles. So that takes care of this and this. But what about this bit, which is connected to a rectangle? Now I need the circumference. What's the circumference? Oh, those are rather large, aren't they? Oh, circumference would be diameter times pi, or 2 pi r. So if I go 2 pi r, it would be that, which is 8 pi. So that would be 8 pi. And then this would be 12 times 8 pi. So what would I get for my surface area? 16 times pi times 2 plus 12 times 8 times pi. And I get 402.12 centimeters squared. Okay, what's the volume for the last question for today? What's the volume of this shape? Pi r squared times how deep it goes. Pi r squared times 12. 16 times pi times 12 gives me 603.19 centimeters squared. So how did you get 402? Okay, so Edith, sorry, wasn't it Vasile? So what I did was I first looked over here. So the pi r squared over here is for that. Because there's 2 of them, that's why there is a times 2 here. But now I still need to worry about this thing over here. And when I cut this and unwrap it, it's going to be a rectangle. And that rectangle is going to have this 12 on its side here. And then it's going to have this part here is going to be this. Now that is the circumference of the circle. So the circumference of the circle, we can either double this and say, look, the diameter is 8, and then go, well, the circumference is 8 times pi. And so all I do now is I go 12 times 8 pi, which is this part here, right? This represents the area of this rectangle. And then once I add those 2 together, I get my 402. Does that help? And you're quite right, Amelia, thank you for spotting this. It's centimeters cubed.